Hello friends, today I am with a video on few important results on circles whose applications were frequently asked in previous year entrance exams. Now from this diagram too, what I get, these two circles are touching each other externally, and if I have equations of two circles, then from the equation I can find out the center of the circles. And suppose center of first circle, I'm describing the second diagram. If center of the first circle is C1, that is this, and the center of second circle is C2, radius of first circle you can find out from the equation, that is R1, and radius of second circle is R2. And from this diagram second, we can see that the distance between two centers, that is C1, C2, is equal to R1 plus R2. That means if two circles touch each other externally, then the distance between two centers, that is the distance formula between 2 points, that is C1, C2, is equal to R1 plus R2. So this is for second diagram. Now for third diagram, again we can find out centers of two circles from the equation and their radii. In this second case, these two circles are touching each other internally. So from the diagram, I can conclude that if C1 is the center of first circle and R1 is its radius, and C2 is the center of second circle and R2 be its radius, then from the diagram I can get that C1 C2, that is distance between two center, is equal to mod of R1 minus R2. So if I subtract R2 from R1, then I get distance between two centers. Similarly, from diagram 3, what I get, these two circles are not touching each other. This diagram 4, not touching each other externally. So we can see that distance between two centers, that is C1, C2, distance formula between 2 points, this is R1 and this is R2, is greater than mod of R1 plus R2. Similarly, in fifth case, what I get, these two circles are not touching each other internally. So from the diagram, I can find out that this is R1 and this is R2. So from the diagram, what we get, that the distance between C1 and C2 is very small, is even less than mod of R1 minus R2. But in first case, that is in the first diagram, what I get, that these two circles are intersecting each other. If two circles intersecting each other, so in that case, the C1, C2, that is the distance between two centers, is less than R1 plus R2 and is greater than mod of, because the difference between two radii is very small here, so it is greater than mod of R1 minus R2. So only intersection is the condition in which this distance between two centers, that is C1, C2, lies in between two values. In first case, what I get, the distance between two centers when two circles are touching each other externally, then C1, C2 is equal to R1 plus R2. When two circles touching each other internally, then distance between their centers is equal to mod of R1 minus R2 from diagram 3. From diagram 4, what I get, if these two circles are not touching each other externally, then in that case C1 C2 is greater than R1 plus R2. And in fifth case, distance between two centers is very small, is even less than between mod of R1 minus R2. But in the first case, when two circles are intersecting each other, so in that case, the distance between C1 and C2 lies in between R1 plus R2 and R1 minus R2. So this is the condition for intersection. So from these diagrams, one more result we can find out, and that is the number of common tangent in each diagram. In diagram 1, we can easily see that we can draw 3 common tangents here. One is this. Another diagram, another common tangent will be this. And the third common tangent is this one. So if we have to find out common tangents without using diagram, we can just find the centers of two circles and check the relation between the centers and the radii. If C1 C2 is equal to R1 plus R2, so in that case, number of common tangents comes out to be 3, as you can see in the diagram. If two circles are touching each other internally, in that case, we can draw only one common tangent here. So again, from the relation between their centers and radii, number of common tangent in this case, number of common tangents is equal to 1. In fourth case, when two circles are touching each other externally, we can draw 4 common tangents. So when two circles are not touching each other externally, the number of common tangents are 4. Okay. So from here, we can write number of common tangents in this case is 4. If two circles are not touching each other internally, then in this case, there will be no common tangent. So number of common tangents is equal to 0. But in first case, when two circles are intersecting each other, we get 2 common tangents. So in this case, number of common tangents is equal to 2. So what types of question we can get from this part are these. Now look, in this question, if two circles, one is x minus 1 whole square plus y minus 3 whole square is equal to r square, and x square plus y square minus 8x plus 2y plus 8 is equal to 0 intersect in two distinct points, then from common sense we can check that the B option is the correct option. Why? Because only in case of intersection, the distance between two centers lies in between two values. But if all the 4 options are of this type, so in that case, we have to just find the centers of the two circles and their radii, and then just check the relation between centers and radius. So for first circle, C1 is the center. The circle is in the form of x minus h whole square plus y minus k whole square is equal to r square. So center is 1 comma 3 and r1 is here r. But for second circle, which is in the form of x square plus y square plus 2gx plus 2fy plus c equal to 0, that is this form. So this is what the general equation of a circle, and from this equation center comes out to be minus g minus f, and radius is here g square plus f square minus c. So from this given equation center comes out to be 4 comma minus 1, and radius is here g square plus f square minus of c, that is root of 9, and that is just, so what I get, root 9, and that is 3. So my r2 comes out to be 3, r1 is here r, center c1 is 1 3 and c2 is 4 minus 1. If two circles intersect each other, then in that case I have to apply c1 c2 lies in between my r1 minus r2 and r1 plus r2. So from here what I get, distance between two center, that is c1 c2. So distance formula is 4 minus 1 whole square minus 1 minus 3 whole square, that is 3 square plus 4 square, that is 9 plus 16 root 25, and that this comes out to be 5. And according to that result, c1 c2 is in between r1 plus r2 and r1 mod of r1 minus r2. So r1 is here r, r1 is here r, r2 is here 3, and c1 c2 is here 5. So when I use these values here, I get 5, r minus 3, and from here I get r plus 3. So from this inequation, r minus 3 is less than 5, so r is less than 8, and from this inequation 5 is less than r plus 3. So what I get from here, this r is greater than 2, and from these two what I conclude that r is in between 2 and 8. So my correct option is B part. So this is one of the application of the previous result. Another application is this: if you have to find number of common tangents between these two circles, again just check the centers and radii and check the relation between them. So first equation is x square plus, there is no need to draw the diagram, only from the equation and we find out the centers and radii. The center of this first circle is 2 comma 3, and r1 is here, and r1 is here g square plus f square plus c, that is 13 plus 12 root 25, and this comes out to be 5. So c1 is here 2 3 and r1 is here 5. And from second equation, that is x square plus y square plus 6x plus 18y plus 26 equal to 0. Center c2 is here minus 4 minus 3 comma minus 9, and radius is here 9 plus 81 minus 26, that comes out to be 90 minus 26 root 64 is equal to 8. So r2 is here 8. So we get c2 minus 3 minus 9 and r2 8. Now just we have to find this distance between two centers c1 c2. The distance between two centers is 2 minus of minus 3, that is plus 3. 2 plus 3 is 5 square. 3 minus of minus 9, that is plus 12 whole square, and this is 25 plus 144, 169, and c1 c2 comes out to be 13. Now just we have to check the relation between centers and radii. Distance between centers c1 c2 is 13, and this is equal to r1 plus r2. because R1 is 5 and R2 is 8. So what I get, if C1 C2 is equal to R1 plus R2, in that case two circles touch each other externally. If these two circles touch each other externally, then in that case number of common tangents are, look at the diagram. In this case, number of common tangent when two circles touch each other externally is this diagram, and number of common tangents here, what we get, 3. So my answer is, number of common tangent in this particular question is, what I get is 3. So correct option is option A. So this is how we find out number of common tangents. Now another concept is here. Now you can see from the diagram, in first case the circle is touching x-axis. So equation of circle touching x-axis, center is alpha beta, and if this circle touches x-axis, then radius is equal to the y coordinate, that is beta. So equation of circle comes out to be x minus alpha whole square plus y minus beta whole square is equal to beta square. This is what the equation of circle in standard form, x minus h whole square, y minus k whole square. Now in this second diagram, the circle is touching y-axis, so equation of circle touching y-axis is, this is what the center, and radius comes out to be x coordinate of the center. So x minus alpha whole square plus y minus beta whole square is equal to alpha square. So when a circle touches y-axis, so in that case equation of circle is x minus alpha whole square plus y minus beta whole square is equal to alpha square. But in case the circle touches both the axes, then equation of circle touching both the axes. So this is the diagram 1 where the center is in first quadrant and circle is touching both x and y axis. So these are two, what, CM and CL both are equal to A, and the x coordinate and the y coordinate of the circle is again AA. Center is here AA and radius is again A here. So equation comes out to be x minus A whole square, y minus A whole square is equal to A square. But in this case, again circle is touching both the axes, but my center is in second quadrant, so my center is here minus A, and radius is here A. So equation comes out to be x plus A whole square plus y minus A whole square is equal to A square. So this is my second case when the center is in second quadrant. But if my center of the circle is in third quadrant, then center comes out to be minus A, and radius is again A. So equation comes out to be x plus A whole square, y plus A whole square is equal to A square. This is the third case. And in fourth case, center is in fourth quadrant, that is A minus A, and radius is again here A here. So x minus A whole square, y plus A whole square is equal to A square. So in all the cases, in all these four cases, circle is touching both the axes. So this is what the equation of circle in standard form, that is x minus h whole square, y minus k whole square is equal to r square. But in general equation, and general equation of a circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. So from the diagram, if we have to find the length of x-intercept is here AB. So length of x-intercept in the circle is 2 root of g square minus c. So you have to learn this, that the length of x-intercept in the circle is 2 root of g square minus c. But if this circle touches x-axis, then this intercept becomes 0. Therefore, from this general equation, if you have to find the condition when the circle touches x-axis, so condition here is this intercept becomes 0. When I equate this intercept equal x-intercept equal to 0, then my condition turned out to be g square is equal to c. So from the equation you can directly conclude if g square is equal to c in that particular equation, then that circle is touching x-axis. And one more thing you have learned from here, that the length of x-intercept is equal to 2 root of g square minus c. Similarly, if you have to find length of y-intercept, and in the diagram y-intercept is CD, so just replace g by f and you get the length of y-intercept, that is 2 root of f square minus c. But if circle touches y-axis, if the circle touches y-axis, then in that case this y-intercept becomes 0. So when I equate this y-intercept equal to 0, what I get, f square is equal to c is the condition when the circle touches y-axis. And the third condition where the circle touches both the axes is when this circle touches both the axes, then in that case g square is equal to f square is equal to c. So this is what touching both the axes, condition for touching both the axes. When we use general equation, we use these results, and on this left hand side I have given results in standard form. So here are few of the applications. Now look at this question. This question came in 2012. The length of diameter of the circle which touches the x-axis at the point 1, 0. So that means this point is 1, 0 and passes through 2, 3. So 2, 3 is somewhere here. Now from the diagram I can conclude that this A is the center and its x coordinate, if AB is radius, then its x coordinate, the circle is touching x-axis, then it's the x coordinate of this center is 1 and h be the y coordinate, and if this circle touches x-axis, then we know that this radius is equal to the y coordinate, that is r is equal to h here. So in this case this r, AB is r, and that comes out to be h. So this is my radius here, and C is any point on circumference, and the distance between center and a point on circumference is again radius. So what we get, that AB is equal to AC is equal to R, and since the circle is touching x-axis, therefore R is here H. Now if AB is equal to AC is equal to R, so squaring AB square is equal to AC square, and as you all know, this AB is H, so this AB square is H square, or if we apply distance formula, then 1 minus 1 0 square H minus 0 H square and whole root, and then after squaring we get H square. Now from these 2 points A and C, distance between A and C is 1 minus 2 whole square, and we have squared this equation, so H minus 3 whole square we get on the RHS. And after solving this, I get 1 square plus h square plus 9 minus 6h. And further what I get, this comes out to be 10 minus 6h, and h is here 10 by 6, that is 5 by 3. And h is here radius, and we have to find the diameter. So diameter is twice the radius, So my answer comes out to be 10 by 3. So A part is the answer. Now few more applications. Now in this question, the circle is passing through 1 comma minus 2, and 1 comma minus 2 is in the fourth quadrant. So this point is 1 comma minus 2, touching the x-axis at 3 0. So that means this point is 3 0. The circle passing through 1 minus 2 and touching the axis of x at 3 0 also passes through. We have to find the circle, and further that circle is passing through from one of the options. So from the diagram, let A be the center of the circle, let this point be B, and this point is C here. Now from diagram you can get that the x coordinate of A should be 3, and let the y coordinate be y here. And again the circle is touching x-axis, so my radius is here y. So from the diagram, AB is equal to AC is equal to radius, and radius in when the circle touches y-axis, then the radius is the y coordinate of the center. And from the diagram, this AB is y and AC is the distance between 3 comma y and 1 comma minus 2. So distance between 3y and 1 minus 2 is 3 minus 1 whole square. Or if I square both the sides, then what I get, AB square is equal to AC square, and this is y square, and AC is the distance between 3y and 1 minus 2, that is 3 minus 1 whole square, that is 2 square, and y minus of minus 2 whole square, that is y plus 2 whole square. So from here what I get, y square is equal to 4 plus y square plus 4 plus 4y, and so from here I get minus 8 is equal to 4y, and y comes out to be minus 2. Now, equation of circle whose center is 3 comma minus 2 and radius is y, that is 2, is x minus 3 whole square y plus 2 whole square is equal to 2 square. Now just we have to put the options in this equation, and if I put minus 5 comma 2 in this equation, so what I get from here, my answer comes out to be minus 5 minus 3 whole square and 2 plus 2 whole square, and this comes out to be minus 8 whole square, that is 64 plus 16, and on LHS I get 80, and on RHS I get 40. Therefore minus 5 minus 2 is not satisfying my equation. Now when I put 2 comma 5 in this equation, again I have just substitute the value of second option, that is 2 comma minus 5. So what I get, 2 minus 3 whole square and minus 5 minus 2 whole square on LHS, and this turned out to be 1, and minus 49 is equal to 50, and RHS is here 4. So LHS again not equal to RHS. So when I put my third option, that is 5 comma minus 2 in the given circle, then this is 5 minus 3, that is 2 square, and this is minus 2 plus 2 whole square. So my LHS comes out to be 4, and RHS is again 4. So the third option is the correct option. So you can check the fourth option also. So This is the required answer. Now, in this question came in 2014, and what is given here? Let capital C be the circle with center 1, comma 1 and radius 1. So this circle, bigger circle, if its center is 1, 1 and radius is again 1, then the circle will touch both the axes. We can check from the above concepts. When a circle touches both the axes, so in that case, my center is A, and my radius is also A when the center is in fourth quadrant. So from here, the diagram is that the center of this circle is 1, 1. So center is here 1, 1. Radius is again 1. And this bigger circle is C. So this is the radius and this is 1. And if T is a circle centered at 0, comma y and passing through origin, center of the circle T is on y-axis and that circle is passing through origin. So this smaller circle is T here. Its center is on y-axis and if the circle is passing through origin. So in that case, its radius comes out to be y. So radius of this smaller circle is, radius is here, suppose this is R1, this is C1 and R2 is here, radius of the smaller circle is y because the circle is touching x-axis. So radius is y coordinate. So radius is here y. So my R2 is y and touching externally the circle capital C. Now my diagram is correct because the smaller circle is touching the bigger circle C externally and the center of the smaller circle is on y-axis and the circle T is passing through origin. Then we have to find the radius of T. So from this diagram and from our previous result, this R2 is here y. So R2 is here y. This is R2. Now from the diagram, these two circles are touching each other externally. So C1, C2 is equal to R1 plus R2. C1 is here 1, 1 and C2 is here 0, y. And distance between C1, C2 is the distance formula, that is 1 minus 0 whole square, 1 square and 1 minus y whole square. So C1 is here 1 square plus 1 minus y whole square. R1 is here 1. So I write R1 is here 1 and R2 is here y. So R2 is here y. And after squaring, what I get, this is 1 plus 1 plus y square minus 2y. 1 plus y square plus 2y. So from here, 1 is equal to 4y and y is equal to 1 by 4 is the correct. This is y is here, radius. So radius of the smaller circle T is 1 by 4 and we have to find the radius of smaller circle T and my correct option is B option. Now next question. Now in this question, what we have to find out, the center of those circles which touch the circle x square plus y square minus 8x minus 8y minus 4 equal to 0 externally and also touch the x-axis lie on. Now, this bigger circle is x square plus y square minus 8x minus 8y minus 4 equals 0 because its center is 4, 4, that is in first column. So center is somewhere here. C1, 4, 4. Radius of this circle is 16 plus 16 plus 4, that is 32 plus 4 root of 36 is 6. That is R1 is here 36. So this is my R1. So R1 is here 36. Now we have to find the locus of the center of the circle, the smaller circle. So let the center of the smaller circle is H comma K. And the smaller circle is touching x-axis, so its radius should be the y-coordinate of the center, that is K. So radius of this smaller circle is radius is here K. Radius of smaller circle is K here. That is the y-coordinate. So radius of the smaller circle is here K. So R2 is here K. And C2 is here H comma K. And if two circles touch each other, this is C2 and R1 is here 6 and R2 is here K. If two circles touch each other externally, then in that case C1 C2 is equal to R1 plus R2. C1 C2 is the distance between two centers, and we have to find the locus of the center of the smaller circle. So we have to follow the given condition, and given condition is that these two circles are touching each other externally. So distance between two centers is H minus 4 whole square plus K minus 4 whole square whole under root. R1 is here 6 and R2 is here K, and after squaring what I get, this comes out to be H minus 4 whole square K minus 4 whole square is equal to K plus 6 whole square H minus 4 whole square on LHS, and we take this to the right hand side, and after solving what we get, this comes out to be H minus 4 whole square, and this is K square plus 36 plus 12K minus K square minus 16 and plus 8K. So what I get from here, this comes out to be H minus 4 whole square and then 20K plus 20, and just you have just take 20 common from here and just replace H by X and Y by K. So we get the required locus, and this comes out to be X minus 4 whole square is equal to 20 into Y plus 1 whole square, and this is what the equation of parabola. So locus of the smaller circle, when that circle moves with the condition that touching x-axis on one of the side and touching the bigger circle on another side, then the path traced to be a parabola. So I hope this video will help you a lot to understand the concept. So please give a big thumbs up to this video and share it as much as you can. And please subscribe the channel Math Advice.